Hi guys, today we're gonna look at the concept called number systems. Okay, so number systems. So what is a number system? Actually, the number system is used for counting. Okay, number system will contain the symbols which is used for counting. Okay, so there are different types of number systems. Base 1 number system, base 2 number system, base 3 likewise. Okay, so we will be having base 8, base 10, and likewise base 16. Okay, and remember base 2 is called binary number system, and base 8 is called octal number system. Base 10 is decimal number system, you know already. Okay, and base 16 is hexadecimal. Okay, so let us see what are all the elements will be there in each of the bases. Okay, so in base 1 number system we will be having only one element, that is 0, and in the base 2 or binary number system you will be having two symbols or two digits, that is 0 and 1. In base 3 we will be having 0, 1, 2. Likewise you can now guess. Okay, so in base 8 we will be having 0, 1, 2, 3, 4, 5, 6, 7. That's it. Okay, up to 7. And in the base 10 you know already, from 0 to 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, up to 9. And in the hexadecimal you will be having 6, 7, 8, 9, and you will be having A, B, C, D, E. Okay, so let us see once again. In base 1, one element, that is 0. In base 2 we have two elements, that is 0 and 1. Base 3, three elements or three symbols, those are 0 to 2. Okay, in base 8, which is also called octal, you have number of elements as 8 and the number starts from 0 and ends at 7. Okay, so in base 8 or octal number system you will be having from 0 to 7, and in the base 10 you will be having from 0 to 9, and in the base 16 or hexadecimal number system you will be having from 0 to E. Okay, so here up to here fine, and in the place of 10 you put A, the place of 11 they put C, and 12 is C, and 13 is D, 14 is E, and 15 is F. Up to 15 you will be having in this hexadecimal number system. Okay, so if you wonder why they have taken A instead of 10, so I'll explain you. So if you take 100, you can represent this in only one form in any of the number systems here available. Okay, including this. So if you take 10 in the place of A, then 100 or 100 will be having two representations. One is 10-0 and 1-0-0. I mean to say that here in the place of A, if you take 10, okay, So see, for 100 you can take 10 and 0, 10 and 0, and 100, 100. Okay, for a single number you have two representations, so that will create ambiguity or confusion. So in order to avoid that, they take symbols. Okay, so if you want, so if you want base 70 number system, then you take after f g, you will take up to g, like that. So here they are representing each number by a single letter or a character. Okay, so the main aim is each number or each digit will be represented by only one letter or one character. So here if you see, if 10 is represented by two characters or two symbols, then that would create a problem here. That is why they are using only one character. Okay, and one more thing, in any number system, okay, in let us suppose in the base 16, the numbers or the digits will start from 0 all the way up to 15. That means 0 to 0 to n minus 1. So n is a base here. If it is a base 16, then you'll start from 0 and you'll go up to 15. If it is a base 10, so you'll start from 0 and you'll go up to 9, likewise. Okay, and one more point is that each and every number in the number system will be less than the base. Okay, so if you see any number, that will be less than the base, and if you see any number here, that will be less than the base. Okay, so base number will give you the number of digits in the number system, respective number system, and each of the element in the number system will be less than the base. Those are all the two important points considering the number system. Okay, so if you wonder where base 1 is used, so I'll take example and I'll tell you. So base 1 is actually used in the primitive ages, in the stone ages. Okay, so like I'll take example. So let us suppose this is a farm. Okay, so a person owns this farm and he has 5 cows. Okay, so in those days people don't know how to count, so what they'll do is they put a stones. Okay, so they have stones, and in the morning they leave the farm. So if the first cow leaves, then he'll put a stone this side, and on leaving the second cow, and if the second cow moves, then he'll put a stone this side, and if the third cow leaves, then he'll put a stone this side. Likewise, if all the cows were left, then all the stones will be this side. Okay, and in the evening again the cows will be back to farm. Okay, so if the first cow enters, then again he'll put stone this side, and if the second cow enters, he'll put a second stone. Likewise, if all the cows entered into the farm, then all the stones will be this side. Okay, or else if any stone is left on the other side, then that will give him a conclusion that some cow has not reached the farm. Okay, that is how they used to count in the olden days. And next came base 10 number system or decimal number system, which is very familiar to you. Okay, we have 10 fingers and we used to count using fingers. And then came base 2. Okay, base 2 started when computer era started. Okay, so and then base 8, base 16. Okay, so you'll also have base 4, base 5, base 6, base 7 also. Okay, those are not much important. So the represented ones, binary, octal, decimal, hexadecimal, are very frequently asked in the examinations also. So we'll be more focused on that number systems. Okay, so if you have a digit or if you have a number in base 2, you can easily convert that number into base 8 and base 16. Okay, I'll take example. Okay, so let us suppose this is a number. Okay, this is a number in base 2. Okay, so what will be the number in octal? Just group 3 digits at a time, then that will be a number in octal. Okay, so this will be a number in octal number system. Okay, so 101 is 5, 100 is 4, 101 is 5, and 011 is 3. 5453 is the number representing the same number in octal. So if you group 4 numbers at a time, then that will be in the hexadecimal number system. Okay, so what will be 1011? 1011 will be 101 is 5 into 2 plus 1, that will be 11. Okay, 11 means 10 is A, 11 is B. Okay, and 0010, so that is 2, B2, and 1011, that is B2B. Okay, so the same number, this same number will be represented in hexadecimal number system with this representation. We just had grouped 4 bits at a time and we got this number. If you group 3 digits at a time, then you will get this number in octal number system. Okay, so why do we group this number into only 3 at a time? Because 2 power 3 is 8. Okay, that means, so if you group 3 bits at a time, then that will convert your number in binary to octal. If you group 4 bits at a time, then you can convert the binary number into hexadecimal number. Okay, this gives how many numbers you have to group in order to convert into that respective system or number system. Okay, this is about the number systems introduction, and let us see the classification of a number system.